Okay, everyone. Thank you for joining us. Let's start the class. There are many type of system. I taught before also. Like static and dynamic system, causal, non-causal system. The next one, time variant and time invariant system. Just I want to focus this one because it's only used in an LTI system. Time variant system, it means which one vary with respect to time. Time to time is varied. It is not directly depends on the input system. If you give some input to the system dynamics will be changed with respect to the time. Such as if you give the input of any system like a unit step at some that time. After some time, you give same unit step input, but the system will be changed. The output will be changed. Then that type of system known as time variant system. In time invariant system, that all the condition system only depends on the output depends on the only input. Okay, let's do something how to check the system time is varying or time invariant system. For this, just think about like your input is xt, then you have output something yt. There is a system between them. There are two conditions. First condition, suppose if you want to add some delay on output signal. After that, you want to add some delay in the system. Output, what is the output? Output will be t plus or minus d something. Any delay. Suppose if you take you only delay, then minus. If you go to the advance, and there is a plus. Another thing, think yt have some delay of in input signal. Then after you have xt minus d, then you have a system. Suppose if you take this one is y dash t, some other output. In both conditions, if a system before the delay or after the delay, if both are the equal for same input, there is no difference between if you use the delay between before the system or after the system. In the both condition, the output will be same. Then that condition, that is known as the time invariant system. That the system is not varies with respect to time. You give some delay before the system, after you give the delay after the system, then there is no changes between them. That system known as the time invariant system. If there is a not equal to this, it means if y dash t equal to y t minus d, this system is known as time invariant system. If y dash t is not equal to y t minus d, that system known as time variant system. The system will vary with respect to the time, because of you give same delays but system output will be different. Let's check for some example, then you understand better. If you have a system, have a output t into xt. Okay, first of all provide some delay in time signal. Where is the time? You save the delay like this one. The systems just provide a delay, then this delay is very subject to the time for all time. Yeah, so simply replace t with t minus d here in this condition. Then y t minus d is equal to t minus d and x t minus d. This is question number first. This is known as y t minus d. Second thing, they give some delay in input only. The input delay, there is the input and this is the input. This input goes to the system. And this that one known as y dash t. It will be t is same as and x t minus delay provide only the input. Equation number 2. You can see the equation first and equation first is not equal to equation second. Or you can say y dash t is not equal to y t minus d because of this one. This is t minus d. The delay provide for all system, all the thing in time. Then this is the y delay time. Second one is a delay provide only in input signal. In that condition, this is the y dash t. That's why the system is well time varying system. This system is time vary with respect to time because of this one. Next example, I take suppose yt is equal to x into alpha t. There is some scaling into time. Then if you deploy some delay or if you at some time the system will be different. Behavior is the different. First of all, like t minus d, t replace to t minus d, this will be x alpha t minus d. This will be x, you can say alpha t minus of alpha d. Second thing, input only, then alpha t minus delay. This is also not the same thing. There is a delay only in the input signal. This is the whole input signal. You provide some delay, the whole input signal. But here it provide delay in the system also. In the same condition, y dash t is not equal to y t minus delay. That's why system will be time varying system. Then what is the time invariant system? Let's check another example. Y t is equal to x t. Suppose there is some x t minus plus minus t. If the system looks like that, let's check for this. Simply t replace t minus d then y t minus d equal to x t minus d plus minus 4. At the same you can write like t plus minus 4 minus d. Okay. Second, y dash t is equal to provide the whole delay x t plus minus 4 minus d, some delay. Then you can see both are the same. Y dash t equal to y t minus d. In this condition you can say the system will be in time invariant system. This type of system is valid in LTI system also. All the differentiator and operator, all the operator are time invariant, like adder, subtractor, differentiator, summation, integrator, all of thing is time invariant system. You can note down like y t d by dt xt. This is the, if this one is the time invariant system, it will not affect to the time. Same thing integrated also same as time invariant system. Because of differentiation you can write this one xt minus of x t minus f h divided by f h, where h tends to 0. If you delay provide some delay in t, then you can see the all both are the same, y dash t and y t minus t. That's why this type of operator is also time invariant system. Next system is linear, linear and non-linear. Linear and non-linear system is defined by two things. If the superposition and homogeneity is verified in any system, then that system is the linear system. Except that the all system is non-linear system. Then what is superposition and what is the homogeneity? Superposition also known as the additivity. Like if you have a system y1 t is equal to x1 t, another system is y2 t is equal to x2 t. If you add these two systems, the input, if you add these two, the output will be same at y1 t plus y2 t. This type of system is verify the superposition. You also know about superposition in a network theory, where the all registers is there, and you add the voltage and current at any element by any sources, and in a final you add the all the voltages by the different sources, then you will find the final voltage and current on that system and that element. But you can't do the power at the same time, because of the power is non-linear system. You can't add the directly, because of there is a I square R. This is the power loss. Then the I square is the non-linear system. If you suppose if you have a input of add the summation of the two input or others also, then output will be same add of the output of the different system, like that. This time if this one is the follows, then the system will be superposition system. Verify the superposition or additivity. Same thing in homogeneity. It's that also known as the scalability. Scalability. If you scale the some system, like if you have input of xt, and then the input gives some output yt, and after that if you multiply of some scalar in the input, then same scalar will be also multiply on the output. Thus, if this system is verified, then our system will be linear system. Yeah, it's homogeneity system. And the final, if both are the verified the system, both condition is true for any system, then that system is known as the linear system. For the final, if you combine both in a system, suppose if you have xt like that, a1, yeah, a x1 t plus b x2 t, like that, then output also should be as a y1 t plus b y2 t. This scaling property shows the homogeneity and the summation of the two system, two inputs denoted through the additivity or superposition. If the both are the verified, the both are condition is true, then that system is a linear system. Okay, let's check for the some system from example. Like first one, yt is equal to a into xt. Take a two system like y1 t equal to a x1 t. Same thing, take y2 t is equal to a x2 t. Then y3 Suppose x3 is some input, the sum of these two a x1t plus a x2t, then what is the output? Output in this condition is same as the scalar of this one. Or if you want to multiply of something like k1 in input and k2 in second input, then this is the k1, a into xt is a y1t plus this one is the y k2 into y2t. Both are the true for the superposition and homogeneity. Then that type of system is known as the linear system. Same thing we want to check for yt is equal to xt square. Some constant, take some constant a xt square. If you want to replace this axt from the another signal like some constant k into axt, then what happen? Then this is the, if I take the output of this one, then we will find the k square of axt like that. It is not just a k. In that type of system is also nonlinear. It's not to follow the homogeneity. If same thing, if you want to check the additivity, then this is also not fine. It is not valid for the superposition also is not valid for this one. That type of system is the non-linear system. In the line you know about mx, y is equal to mx, the system also a linear system. Why this slope is m, but x square, this is the non-linear system. Okay. Let's go to the LTI system. LTI concept of LTI system. Simply we have some input and this gives some output xt and yt. Between them this is a system known as the LTI system. LTI means this is the linear, this is the time invariant. This is the linear. Linear have two properties, additivity or superposition. Second one is homogeneity. With this LTI system follows these things, additivity, homogeneity and time invariant. It, in the system you give some this type of system is give the some input to the system, then this is the process, do the process by this LTI system, then gives some output related to this. Then let's check for the representation, how to represent this one. First one, additivity problem. Check according to the additivity. There is some system xt, which one combination of some additivity, uh, summation of some inputs like x1, x2 plus x3 to n, and the output respected to that input is y1, y2t, this is the output respective to the that input. Second one according to the homogeneity. If you scale some system like xt, give some output yt, if you scale by x or t by k, then output also scale by k. Third one, according to time invariant. So there is some input gives some output by the system. If you provide some delay to the system, same delay will be provided by the system also. If you give some delay to the input, then same delay provided by the output also. There is no changes. If there is any changes between them, if the same delay is not there, then the system is a time variant system. This type of system are generally a difficulty to process, to understand, to learn about the system and to use that type of system. It's difficult. If you combine the all, like if you take some input by combining all of things, some scaling like homogeneity x and some delay provided by them, this is time invariant, and add of some other input also, this one x1 to x1t, this one known as the additivity, all of things in together. And output related to that inputs. If it's scaling a C1, then output also same as the C1, Y1, and delay also same. If you give that input to LTI system, then representation of that one. This is the xt, this is the yt. If you want to combine this one at a summation, taking summation I is equal to 1 to n ci xi t plus minus di, then output also is the same as the respected input ci yi t plus minus di. Okay. Then what happen if you give some input to the LTI system? Then there is a two responses. The impulse, if you give the taken as an impulse signal, uh, output is the process. This, suppose this is the impulse response of the system. You take some delay in the system. This is represented as a time invariant. This system, if you multiply some constant to this system, this is also same as scaling to that system. This one is the homogeneity. In the this is the continuous time. In the continuous time, the system is continuous time. To summarize, integrate this system minus infinity to infinity fx tau dt tau. This is also known as the convolution of the system. This is the output of the system. It means the LTI system represented by the impulse response of the system. This was represented a system represented by this one. HT. HT is when the input is the impulse, a single, one, like one. Same thing if you multiply anything by 1, yeah, a by 1, b by 1, all of things is the same, 5 a and b. That's a system also here. If you in LTI system you give some impulse response, impulse input, then that provides some output. That output known as the impulse response of the system. This is also represented with the system without given any input. This is the impulse input. It's like one only. Then if you multiply some input also, other input also, x tau or some other thing, That one also represented by text out to the output, reflected by the output by the system. This is also you can say this is the known as the convolution system. This form is the convolution system. Output you can take this one. So given some input process by the system and gives some output. That's what known as the convolution. Then how we will find the convolution system? This is also all of the completed here. Additivity you can say also. By integration in continuous time, you add the all of thing. In discrete time, you sum of all the system. In continuous integration is same as in discrete is the summation. Same thing for the discrete time. To find a convolution, what happened? Same LTI system gives some input xn, process some output yn. Same single one response input given this system gives some responses hn known as the impulse response of the system. Sorry. For verify of this one, this was verified the time invariant. Then if you multiply some scalar to the input, the same scalar also multiply by the an output by the system. This one is the represent as the homogeneity in discrete. If you add all of thing in the discrete time, there is a summation in place of integration. Minus infinity to infinity means all xk del l minus k. This process and gives some output respective to that input xk h n minus k. This is known as the convolution in discrete time. This is the process is the additivity. This is the impulse response, the time invariant. These two makes the linear of the system. This is time invariant system. This is the impulse response. When you give some like a sing one is the input. Impulse is the single one. If you multiply by the one in any system is same output is the same. That's why it's known as the impulse response of the system. This is also represented the system. After that, if you multiply some input, then input is processed by the system and gives some output respected to this. In continuous time, convolution of two system is same as LTI system process this one h tau h t minus tau d tau. Ht minus tau is same as the impulse response of the system. This is the input. The whole if you process this one, then you will get the output. Same thing like that. This is the input. This is the output system. This is the output. Input and system have some convolution. After that, we will get the output. You can say the YT is equal to infinity minus me to infinity s tau d minus tau d tau. Convolution of input and the system, find the output. Like here, this is the input, this is the system. If you convolution of these two, then we will get the output of yt. Here you can see this one xt in convolution of ht. For finding this one, you have to do a integration of minus me to infinity x tau into h t minus tau d tau to find the convolution. Let's do by an example. Find the convolution of ut and ht also ut. Both are same. Input I have taken the same as. Then this one you can take as x tau as the input. This one as a system impulse response as tau. This one also you can say x tau is ut. It means unit step signal started from 0 to infinity and magnitude is 1. Same thing as tau also. A unit step signal started from 0, magnitude is 1. Then if our system is unit step and your input is also unit step signal, then what is the output is this question. It means convolution of the both. This is the system and this is the input. Okay, let's try to find. If you give this is the also ut, input is also ut, then what is the output? Then there is the x tau. Take this one as same. Then find the t minus tau. Can you return this one h tau minus t? Then what is the tau minus t? H tau minus t, it means there is some delay t. This one t tau have some delay. This one is a tau because I replaced t as a tau. All of them like that. T is replaced by the tau. And this is the t. No, take as tau. Okay. Then you have to find t minus tau, not tau minus t. Then what to do? Simply scale this one. To take minus tau minus t, same thing. You have to do this one in this process. To do this one, it means this one reflect the signal on the y-axis, like just mirror image. This is a t delay, then t delay is here. And this is signal is looks like that. Reflect to the y-axis. This signal is also known as a t minus tau. This is the same as t minus tau. First, provide some delay as t. Then after, take scaling as a negative. You reflect the signal on the y-axis. This is simply this one will be a mirror image of the y-axis. Then you have x tau and h t minus tau. Then there is some conditions. Where is these two is overlapped or where is these two is not overlapped. Let's check. X tau is this one, 0, tau 1, so 0 to infinity. H t minus tau is this one, t. Case first, if t is less than 0, it means this t is here something, somewhere. Then what is the signal? This is h tau is same as this one, 0 to infinity. But ht minus tau, if t less than 0, then it looks like that before that 0. And between them there is no overlap. There is no overlapped. Then what is the yt? Yt of integration of minus infinity to infinity h tau x tau into h t minus tau d tau. The multiplication of these two is 0 here because of there is no overlap. The multiplication of this one is also 0. Then y equal to 0 at t is equal to less than 0. Case second, with t less greater than 0 or equal to 0. Then what is the function? Now it looks like this one is same as x tau, but t is shifted to here somewhere greater than 0. Then this looks like that. There is some overlap between them. Then what is the yt? Minus infinity to infinity x tau t minus tau d tau. These two, multiplication of these two, will find 1 into 1. There is an overlap between 0 to t only, not a whole minus infinity to infinity. Then you have to take a limit from 0 to t, 1 into 1 into dt. Okay, d tau. And this is the integration of a constant 1 is tau 0 to t, and this is the t. It means yt is equal to t when t is greater than or equal to 0. It means you can say yt is equal to 0 when t is less than 0, t when t is greater than or equal to 0. The same signal, you know about the signal, this is the ramp signal. Less than t is 0, this is the 0 signal, and after t is equal to t 0, this is the t is simply linearly increased. This is also known as the RT signal. It means the convolution of two unit step signal ut is a ramp signal yt rt. Convolution of two step signal is ramp signal. Okay, let's check questions here also. There is an LTI system. Given some input x1t is a step input 0 to 2, and the LTI system process, I'll say there is some system, then there is some component in the system which one made that this input to in triangular input output. It means there is LTI system, input of this one is this one 0 to 2 t xt, output of this one have something like that 0 1 2, this one 2. We don't know about the LTI system, what is there, we don't know about that, but this question is given. Only the input of this LTI system is this one, and there is something in the LTI system, but we don't know, and it process the output is this one. Then what is this in this LTI system? Not given. But in the question is asking, if the input is this one like that, then what is the output? Or the second thing, if the system is looks like that, then what is the output? Is asking in the question. First thing, given as a input of this one, output is this one processed by some LTI system. After that, I will give the input is this one like that. Then asking about the what is the output here and what is the output here. There is LTI system. In LTI system, you can choose as the homogeneity, additivity, and time invariant. In time invariant, you can, it means you can provide some delay. Homogeneity, if you multiply some scalar in input. Additivity, it means you can add some add two signals. These three operation you can do by finding the final answer. Then first of all, find this input. What is this input? Then how can you made by this input? And same process you have to done by the output also. Okay, you can see this one is the same, looks like input. It means there are some summation of two signal. First one is same x1 xt, this is not x1t, take as this one xt, this is the xt. Okay, after that there is some 2 to 4, there is something. Then how can you find this one? If you add this one xt, x1t is summation of xt plus something, then what is this, that one? How can you retain this one? By using x1 xt. Okay, let's check. Xt is this one 0 to 2 1, In this process, if there is some delay we need 2, then provide some delay 2 here. Then what is t minus 2, and what is the signal? The signal is delay by 2. It means this 0 is shifted to here, 2, this 2 is shifted 4, this one is the same out. Yeah, this is the x t minus 2. Okay. Then after, this is the reverse, this is a negative. Then simply what is the magnitude of this one is minus 1, same as this one. It means there is some negative x multiplication, y axis operation is there, x t minus 2. Then we will find this one is looks like that, 2 2 4, this will be minus 1. Same thing if you add this one signal and this signal, then we will find this one. Then you can say xt is a negative, it means negative x t minus 2, you have to x1 t. Let's do by waveform also. They are 0 to 2, 1, another is 2 to 4, this is minus 1. You have to add the both. Then this is this one goes to 0 to negative minus 1, 1, 2, 4, the same as the xt. And xt is this one, x1t is xt minus of xt minus 2. Then what is the output? Y1t is same as, because of the LTI system, this is the yt minus of y t minus 2. If you do same this thing, we will get the output same as the input provided. Okay. Then what is the yt? Yt is given as 0 to 2 triangular wave, 0 1 2, and this is the 2, magnitude of this one also 2, height. Second one is the minus of t minus 2. Then first do y tf minus 2, and how is this one? T minus 2, it means this is shifted to the 2 like that, 0, sorry, this one is 2, 3, this one is 4, magnitude of this one is same as 2. Now this is the yt minus 2. Then after you have to provide the y-axis operation also as a negative, minus of y t minus 2, and this signal is shifted as same as a negative, 2, 3, 4, this was minus 2. Then this was here, 2, 3, 4, add both, then we get the output. How can you add this one? As this one is same to same as 2, 0, 1, 2, 3, 4. From 0 to 2 is same as that signal. Okay, after that we add this one, so it looks like that. This is the y1t output, and the input is this one. Sorry, because of the LTI system, how can you find this one? First of all, find the input. How can you make this input? By adding, subtracting a delay, provide some delay. given some scalability also you can do here by to find the input. If you find the combination input combination, then you will get directly the output combination, same as the input combination. Okay, same thing for the second y2t as y1t y2t. How will find that? Okay, how can you find this one from this one? You can see here there is a -1 to 1 only, dimension is 1 unit here. Previously I will tell you, I, I told you already, you can't we do the scaling thing. It means yt is equal to x alpha t something. This is the not LTI system. This is the time variant system. I taught you before this one, I think here somewhere in LTI, time invariant. This one. This is a time variant system. It means you can't be use this one. Then how can you find the, because of the this is the compression. Compression only possible when you apply the scalar. Yt is equal to else alpha t something. Then there is a problem, possibility to compress the signal, but you can't be use this one because of this is not a time by invariant system. This is the out of the LTI system. Then how can you find this one? You can't be change the width of this. Then there is two widths, and you can see this will be -1 to 1. There is a 2 width, 2 unit of width. Then you can see 0 to 2. Also there is a 2 unit. Then you simply add 2 signal by providing some delay. This one. Xt is 0 to 2. This is 1. How can you shift to left side? By providing some positive advance to the advance signal. This is the -1 0 1, and this is the x2 xt. If you add to both xt plus xt plus 1, then we will get the out input of x2 like that. This is the 0 to 2 xt. This is the xt plus 1 -1 0 1. If you add this one, sorry, then not depend this one. To add is to start from -1 to 0 at same as same. This is the 1 1 add up, it will goes to 2 from 0 to 1. After that, this is the only this signal is presented to 2. This is the same as looks like x to t. It means x to t is written as xt plus xt plus 1. Then what is the output? Y2t is same as yt plus yt plus 1. 0, 1, 2, 2. This is the yt. Second yt plus 1. It means this will be shifted to left because this is the advanced signal. Minus 1, 0, 1, 2. We have to add this one. This will be started from minus 1, 0, 1, 2. Started from minus 1, same as slope, and goes to 2. Then the after this one slope, this will be decreases. This is the increasing, this is decreasing. If you subtract at the same slope, both are the same slope, then we will get the same constant output. Then after this will be 0, is only this one presented. Then this will be looks like that. Trapezoidal. This will be the y2t. Which one is yt plus yt plus 1. This is the 2, this is the 0, finally is 2. To add the here also, this 2, this 0, this is a 2. And between this one also the slope will be cancelled out, only a straight line is there. Okay. Yeah, there is a two rectangular but different width. To find the convolution between them, this is the st, this is the xt. Then how can you find the convolution of these two signal? Okay. You have to, this is the st. First of all, take as a tau, this is x tau. We have to find h t minus tau. Now can you find? First find t tau minus t. Tau minus t, it means this will be shifted to some value t. By the shifting towards the right hand, you have to add some t. Okay. Then you reflect the signal, that same signal with respect to the y-axis by taking a negative tau minus t, and this is the h t minus tau. Because of the this is the symmetry signal with respect to the y-axis, then this will be same. There is no change between them. This is the 1, 0. Okay. We got the both. This is the x tau, the t minus tau. Then let's start doing this one. Case first. Take as case first. X tau. Find the x tau. Minus 2, 2, 1. x tau. As a t minus tau, if this one 1 plus t is less than this one minus 2, we start from here and so slowly goes to right, left to right. We can start from right and slowly goes to left to right to left. You can use both things. Okay, I use the from left to right. Then simply, if this thing is less than minus 2, it means this h tau is here somewhere. This is minus 1 plus t, so 1 plus t. Then what happened? There is no overlap between them. Then you can write yt is simply 0 because of no convolution rules. Minus me to infinity x tau h t into t minus tau d tau. This is the 0 because of there is no overlap. Okay, case second. In second case, suppose this one is greater than this one, the 2, but less than these two. It means this will be here somewhere. 1 plus t is greater than of minus t, and same 1 plus d is less than of 2. In this condition, you can simply say the t is less than of minus 3. In this condition, you can say the t is greater than of minus 3, but t is, yeah, you can see, yep, or take this one. This will be greater than minus 2, but this thing is less than minus 2. Minus 1 plus t is less than of minus 2. It means greater than minus 3 but less than minus 1. And combine this one, you can say t is minus 1, greater than minus 1, and greater than minus 3 and less than of minus 1. Then how it looks like? If one, this will be same as previously, minus 2, 2. This was looks like this one, minus 1 plus t, this is 1 plus t. Then there is an overlap between them from minus 2 to 1 plus t. This is the integration limit to find the output. Yt is equal to minus 1, minus 2 to 1 plus t, multiplication of 1 into 1 only d tau. Then this is the tau only, this is minus 2 1 plus t. Yt is equal to 1 plus t plus 2, because of minus and minus will be plus, and yt is equal to t plus 3. When minus t minus t is greater than minus 3 and less than minus 1. This yt is equal to 0 when t is less than minus 3. It means signal will be start from minus 3. Before minus 3, all is the 0. Case 2 is completed. Next for the case 3. In case 3, this will be this also greater than minus 2. This lower portion, lower limit also greater than minus 2, but the upper portion is not more than 2. This will written as minus 1 plus t is greater than of minus 2 and 1 plus t is less than of 2. Then this is also t, it means greater than minus 1 but less than 1. Then how signal is looks like. Minus 1 of t, this one is greater than minus 2 but this one less than 2. It means this will be between them. Between here to here somewhere. Minus 1 plus t, 1 plus t. Then find the yt. Yt is limit. There is a one overlapped here from minus 1 plus t to 1 plus t. The area 1 into 1 into d tau. Then there is a tau minus 1 plus t, 1 plus t. This is 1 plus t minus minus plus 1 minus t. This is the 2. Constant 2 is there. It means yt is equal to constant 2 when t is greater than minus 1 and less than 1. Between minus 1 to 1 there is a constant 2. Next one, case 4. Case 4, it means this one will be greater than 2 but this one will be less than 2. 1 plus t sorry 1 plus t is greater than 2, it means, and minus 1 plus t is less than 2. T greater than 1 but t is less than 3. Then signal, how it looks like the signal. Minus 2 to 2, this is 1 is greater than, yeah, minus 1 plus t, 1 plus t. There is an also overlapped from minus 1 plus t to 2. And yt from minus 1 plus t to t. Multiplication between this one d tau tau. There is a tau minus 1 plus t to 2 plus 1 minus t. Yt is equal to minus t plus 3 when t is greater than 1 and less than 3. Case 5th, last case. Sorry. When minus 1 plus t is greater than of 2 also, then it means t is greater than 3. In this condition, this will be outside the signal. The whole signal will be 0 because there is no overlap. Minus 2, 2, the signal is there. Minus 1 plus t and 1 plus t. This is 1, 1. There is a yt is equal to 0 because there is no overlap when t is greater than 3. yt is equal to 0 when t is less than minus 3 in first case, 0, second case t plus 3 when t is greater than minus 3 but less than minus 1. This is 2 when t is greater than minus 1 and less than 1, minus t plus 3 when t is greater than 1 and less than 3, 0 when t is greater than 3. Then the signal, how it looks like. 0, suppose there is 1, 2, 3, minus 1, minus 2, minus 3. System is 0 before minus 3. Then if greater than 3, this will t plus 3. It means there is a ramp signal. Is a ramp started from t minus 3, then minus 1 till minus 1, then t plus 3. Suppose someone is you sum xt is t plus 3, then at minus 1, what is this one? Minus 1 plus 3 is equal to 2. 1, 2, 3. It means there is a 2 here somewhere. Goes to 2 at minus 1. Then still 2 when goes to 1 also. Goes to 1 at same constant. Then after this will be a negative slope from 1 to 3. Yes, there is a negative slope. Then after again 0 for greater than 3. The system it looks like that. Trapezoidal, when you multiply of two rectangular at different width. If you multiply up two rectangular at the same width, then this will be the cancel out. This will be some triangular only. You can try. Okay. You know about in previously I'll tell you. I told you I think UT is ramp signal. Okay. Then let's try to solve this thing. Another thing, if you have some delay of alpha here, suppose some advanced signal yt plus beta is there, then what is the rt? Rt is the t plus beta plus alpha plus beta. Okay, if there is a negative, then this is a negative, this is positive, this is positive. Then let's try to solve this one by simply multiplication of the corner. This is minus 1 1, this is the st, and convolution of this one minus 2 to 2 xt. For this one, first write the equation for this. Then you can see this is the step signal started from -1. Okay, it means you can write as st is equal to u t plus 1 because of the start from -1 plus 1. Then after this will be some 0 goes to 0 because of there is some step signal subtracted from this one. This is the minus u t, delay is there, then this will be plus st is there. You can write st like that. Then yt, xt, same thing, x for the xt. This started from -2, then you can write t plus 2 started minus of u t minus 2. Okay, t plus 2 minus u t minus 2. Then convolution of this one ht xt u t plus 1 minus of u t, sorry this will be minus 1 because of this one. Another signal started from here, then both are cancelled out, that's why this will be 0. T minus 1. Convolution of u t plus 2 minus of u t minus 2. Same thing, multiply this one to both, then after multiply this one to both and write the answer. If you multiply this one to this one, ut plus 1 into ut plus 2, then there is ut plus 1 plus 2. Because of I give it this one ut plus alpha plus into ut plus beta is sorry rt plus alpha plus beta. Okay, this is not a u, this is the r. Rt plus 1. Okay, then same thing multiply of this one, negative should be negative, and this is the also unity step. Multiply of the unity step is ramp signal rt plus 1, this will be minus 2. Then both are completed. After this one, this will be also minus y step signal multiply with step signal is ramp signal t minus 1 plus 2, then minus minus will be positive, ramp signal t minus 1 minus 2. You can rewritten this is the yt is equal to r t plus 3 minus r t minus 1 minus of r t plus 1 plus r t minus 3. Okay, this is the final answer. Then how can you draw the signal by this equation? Zero, 1, 2, 3, 4. This will be minus 1, minus 2, minus 3 minus 4 is given. There is a ramp signal started from t plus 3. It means there is a t plus 3 here. Okay, then it is subtracted the ramp signal from t minus 1. There is a t plus 3 to minus 1, then there is a minus 1 at minus 1. The same, because of there is a 1, there is also 1, slope is same, but for the same slope, if I subtract from the ramp signal, there is some constant, goes to constant to, there another ramp signal is subtracted from the signal from at plus 1. It means this goes to plus 1. Okay, then at t plus 1, there is another ramp signal, slope is same 1, goes to downside, goes to negative slope till t is equal to 3, goes to t is equal to 3. Then at t is equal to 3, the another ramp signal is add up at the same slope 1. Then if there is a negative, another same signal is add up at this one, the whole signal will be 0. And this signal looks like that. For the find magnitude of this one, you can use this one. At t is equal to minus 1, put rt plus 1. It means this will be t plus 3 at t is equal to minus 1, then minus 1 plus 3 is equal to 2. And this will be like this one. This is 2. Here you can simply add, this is the one slope, a single slope, then there is a 2 magnitude, 2 units is deflection, then same 2 units is also here because of the 1 is the slope. That's why this is 2. Okay. This all about the continuous time signal. And what happens if there is a discrete time convolution? How can you find the discrete time convolution? All of thing is continuous time convolution. I have taken some direct example of this one. Discrete time convolution, like same LTI system, you give some input xn and process output is y1, system is hn. Then what is the yn? Yn is equal to xn convolution of hn. Then for the discrete time, it will be a summation of, you can say, k is equal to minus infinity to infinity xk into h n minus k. Okay, same thing is there in the continuous signal is integration. Here is summation. take some example. Example. Find the convolution of simple un, convolution of un. Take one is xn, another is hn. Then you have to find n minus k. Then take as this one is a k xk, this is the k hk. You know xk is un. Un should be represented as a signal, step signal, unit step signal in discrete time like that 0 to 1. Hk is also same because of this is also un. That you have to find n minus k. The same thing you apply. First check h k minus n. Right, k minus n, it means it will start from 1. Sorry, n. Then this signal take scale t of this one. That signal is simply mirror image of the y axis by n, and this signal is same as h n minus k. Okay, you have two signal, this one and this one. Then let's try to find the convolution. Test first. Same if n is less than 0, then there is no overlap. Case 1, if n is less than 0, then how looks the signal? The signal is this one is xn, xk. Another signal is this one to n, but there is no overlap. Then y1 not, yn is equal to summation of k is equal to minus infinity to infinity xk h n minus k. The multiplication of xk and h minus k is 0, then yn is 0. Second thing, case second, n greater than or equal to 0. There is a two corner only, 0 and n. That's why only two cases possible. When n is less than 0 and n is greater than 0. Then how the signal is looks? Infinity is xk. Second one is y when this is the length is same, goes to n, this is 0 to n. There is an overlap between 0 to n. Then yn is equal to summation of k is equal to 0 to n xk, xk is 1 into yn, hk minus k also 1 because of the 1 magnitude. The summation of this one 0 to 1, what is 1 is constant 1, there is no not present of k, that's why the 1 is 1. When we present 0, k is equal to 0, that's value is also 1, and when present k is equal to 1, that's value will also 1, always 1. But to n, okay, but you just image this one, this is when k is equal to 0, but this is from k is equal to 1 to n, that's why there is a number of terms is n here, but this is the extra term, the total is element is n plus 1, not n, because of the 0. Then you know about the, this is all 1 1 1 1 is in AP, arithmetic means series. In this that one you know about in AP series, sum is equal to n by 2 2a plus n minus 1 into d, where d is difference, a is first number, a in total number, here is n is n plus 1, n plus 1 divided by f2, first digit is 1, 2 into 1 plus n, there is n plus 1 minus of n, d 1 minus 1 is 0, d is equal to 0, that's why you can say n plus 1 by 2 into 2 plus 0, it means n plus 1, summation of all of thing is n plus 1. But there is a multiplication of un, that's why we have to write the limit also. N plus 1 is a whole, minus 1 to 1 minus me to infinity, then you can't be say that one same as, you have to provide some limit, then you can see a yn is equal to summation of k is equal to minus infinity to infinity xk hnk is equal to n plus 1 into un, because there is a convolution between un and un, the signal is only on more than 1, more than 0, not less than 0 percent, that's why un have to multiply. Okay, let's check another example. Alpha is equal power n un, convolution of un. Okay, take someone, this one is the xk, this one is the hk, you know, h n minus k I already find for the un, it will be looks like that to n. If the alpha un alpha is mod alpha is less than 1 from this, from for this question, then the alpha n is, if n is minus infinity to infinity, if n is equal to infinity, the power is infinity, then this will be reduces like that. If infinity is minus infinity, then alpha power n is equal to 0. Okay, it means this is the alpha power n where alpha is less than 1. Okay. The same thing if alpha is greater than 1, this will be order is reversed. But multiplication of this one is un. That's why the whole signal will be cancelled out 0, only this signal is present. Then you can say the alpha power n un is equal to this one. Okay, this was like that. Convolution of this one, same thing, n is case 1, n less than 0, convolution of this one will be 0 because of there is no overlap. Case second, when n is greater than or equal to 0, there is an overlap. This signal is looks like that, xk, y, hk is simply magnitude of 1, to n, 0 to n is the overlap, yn is equal to summation of k is equal to 0 to n, 1 into alpha k. This will be looks like 1 plus alpha square plus alpha cube dot alpha power n. These are n terms. For AP, in AP, sum of 1 plus alpha square plus alpha cube plus dot alpha n are in GP. If they are in GP, then the common ratio is alpha by 1 is equal to alpha square by alpha all about alpha. The sum of this series is r to power n minus 1 divided by r minus 1. That's why this will be the same, looks like alpha power of n plus 1 minus 1 divided by of alpha minus 1. Is also presented to with un after the 0. This is the answer. Or you can say remove this one, you can say n is greater than equal to 0, or if n is less than 0, this will be 0. Okay class, I want to stop here, and later and next class I will tell you about the finite time duration of convolution for the discrete signal. Then after start with the Laplace. Okay, thanks to all.